Okay, so next topic is SOP and POS forms. Now SOP stands for sum of product. This is sum of product, and this POS stand for product of sum. We'll see here product of sum. So these are the two basic forms of Boolean expression. So any Boolean expression can be written in the form of this SOP and POS. So sum of product, when two or more product terms are assumed by Boolean addition, the resultant expression is sum of product, like this. You can see like this. So a function is given here, function of a, b and c. So if you write like this, a dot b plus a dot b dot c plus, so you are writing like this. Okay, so this is basically, this is the product, this is also again product, this is product, so this is sum of product. Okay, the product is added, so this is sum of product. Okay, product, then addition, so this is sum of products. Another form is product of sum, so you can write like this. So these are the basically, these are the sums, and then at last we have a product. So this is product of sum form. So two basic forms are there, always remember this, SOP and POS, sum of product and product of sum. Now another term is non-canonical and canonical. So let us start with the non-canonical forms. Now if all the variables of a function are not available in each term, for example, if let us say we want to write SOP form, specifically the non-canonical form. So here see here you can see here this function of ABC, a dot b. So c is missing here. Okay, because three variables are there in the function a, b and c. So here a dot b, so c is missing here. In the second term we have all the variables a, b and c, and in third term we also have c missing here. Okay, so all the variables of the function are not available in each product term. Okay, so if all the variables are not available, then it would be a non-canonical form. Similarly, we can write for POS form. Now here again, see this is a function of ABC. This is C is missing here. All three terms are there. Again, C is missing. So all the variables are not available here. So this is a non-canonical form. Now let us move to the canonical form. If all the variables are available, like this, function of A and B. Now here only two variables are there. So let us take an example. This is given, function of A, B and C. Three variables are there. If you are having like this, A dot B dot C plus A bar dot C bar dot B bar. Now here all three variables are there. Again all three variables are there. So this is a canonical form when we have all the variables available. Okay, here it is two variable only, A and B. So A and B are present in both the terms. Similarly, we can write for this POS form. This is two function again. Two variables are there, A and B, and both are, you can see here, both are available here. Okay, so you can also write like this. Let us take the example of the three variable now. A, B, C. That would be equal to A plus B plus C bar. Okay, we should have a term, whether it is in bar or simple term, but we should have all the three terms here. Okay, so multiplication is there, A bar plus B plus C. So all three variables are there. Again all three variables are there. So this is a canonical form. Again, you can see it. Okay, simple rule is there. If all the variables are present in all the terms, then it would be a canonical form, otherwise it is a non-canonical form. Now non-canonical forms are reduced form. For the realization of the gate and to make a particular circuit, we require a non-canonical form. Okay, now this is a, you have to identify. So let us say that four terms are given: 1, 2, 3 and 4. These are the four equations, you can say that. Now you have to identify which term is canonical and which is non-canonical. So you have to identify it. Okay, now see here, all three variables are there, again all three variables are there, again all three variables are there. Okay, so it should be canonical form. Now come to the second one. Now here three variables are there. Now here only two variables are there. A is missing here. Okay, again A is missing here. So this is non-canonical. Again come to the third one. Three variables, three variables, three variables. So this is canonical. Now this is a question mark is here. If it is given that you have three variables A, B and C, okay, then this fourth one would be non-canonical. If only two variables are given B and C, then it would be canonical form. Okay, so answer is like this: canonical, non-canonical, canonical, non-canonical. So this is a, just put a star here. This is conditionally non-canonical. Okay, variable are not given. Clear? Now come to the next one, Minterm and Maxterm. Now before going to this Minterm and Maxterm, you have to know that. Now see here, let us say you are having OR gate, AND gate. Okay, for this let us say you are having two input 0 0 0 1 1 1 1 0. Okay, let us write it here: 0 0 0 1 1 0 1 1. Okay, so for the OR gate and for the AND gate, what would be the output? For the OR gate, for 0 0, what would be the output? 0. For AND gate, it would be 0. You will get 1 here, you will get 0 here, you will get 1 here, again you will get 1 here. Okay, I'm just getting the, because the screen, back screen is white, so I'm getting some problem writing on this. It should be black. Okay, so just remember this. Now for the, you have to write down the basic equations for the, let's see now, the black is visible? No, it is not visible again. For the AND gate, you will get 0 0 1. Okay, for the OR gate you get 0 1 1 1. So what you are getting for the this 0 0 input, what you get in the OR gate? You get 0. Okay, for 0 1, what you getting? You are getting maximum term here for the OR gate. For 1 0, you are getting, which is maximum for one from this 1 and 0. 1 is maximum, so you are getting maximum term. Okay, and for the AND gate, what you are getting? You are getting minimum term. So AND operation will give you minterms, and OR operation will give you maxterm. Okay, simple. Remember this: OR operation will give you maxterm, AND operation will give you minterm. So just write down the equations of OR gate and AND gate. Just see, out of these two inputs, let us say one input is A, another input is B. So out of these two inputs, what you are getting? You are getting a minimum of this or a maximum of this. So what you are getting? You are getting, so for the OR gate, you will be getting maximum of these two you are getting, and for the AND operation you are getting minterms. Now tell me, the one form is SOP, another is POS form is given here. Now see here, so AND operation is giving minterms. Okay, so that this operation, this is the sum of product form, so these will give you minterm, and addition of minterm will give you minterm. Addition of minterm will give you minterm. Okay, and what this POS form will give you? Maxterms. Okay, because OR operation is there, so addition of the product of Maxterm will give you Maxterm. Okay, so SOP will give you minterm and this POS will give you Maxterm. Just remember this simple rule is there. Okay, now so you will write like this. Now if you want to write minterms, so you need to remember this. Let us change it to another color. Okay, so let us say that this 0 is A is corresponding to this 0, so that is A bar here, this is B bar here because B is 0 here. So this is corresponding to A bar, this is corresponding to B, this is corresponding to A, this is corresponding to B, this is again 1, so this is corresponding to A, this is corresponding to B. So you are getting AB here, you are getting AB bar here, this is bar here. Okay, you are getting here A bar B and you are getting here A bar B bar. So these are the corresponding minterms. If you want to write for this, these are for 2 variables. If you want to write it for 3 variables, so here what you are getting? Here you are getting A bar, B bar and C bar because both are all are 0 0. So you are getting here A bar, B bar and C. You are getting A bar, B, C bar. Here A bar, B, C, A, B bar, C bar, A, B bar, C, A, B, C bar, A, B, C. Okay, so this is how you can write down the corresponding minterms. Okay, now if you want to find out the expression, if you this equation is given to you, a truth table is given to you, you have like this, you have 3 inputs, A, B and C are 3 inputs and 1 output F. So you can say this function is A, B, C and you have to find out Boolean expression, corresponding Boolean expression. So you can do it like this. So these are the inputs and F is output. So you are doing it for SOP, sum of product form. Okay, we are not dealing in POS right now. We are doing it for the SOP, sum of product form. So you have to just see this row, see this, and find out where are ones. So this is a 1, mark the ones. Okay, this is a 1. So 3 ones are there. So just check the value corresponding to these ones, the value of A, B, C. So here this is A bar, this is B bar, this is C, and this is corresponding to this. So this is A, B bar, C bar. Okay, now this remaining one is, this is B, this is A, this is C bar. Okay, so you got these values, you put these values, so you will get this function of ABC would be equal to A bar B bar C plus A B bar C plus A B C bar. So all these values of this where you have a ones in a function. Okay, and these will give you minterms. So this will be equal to M1, M4 and M6 because at what position they are. This is 0 position, 1, 2, 3, 4, 5, 6, 7. So 0 to 7. Okay, so this is, which position is this? This is position M1. Okay, and which position is this? This is M4 and this is M6. So you are getting the minterms at M1, M4 and M6. So you are getting once at these position. So you can also write like this. Okay, this is the writing way of writing of minterms. So you will write summation. The small m is there, 1, 4, 6. So at these positions you have ones. Okay, so how will you write max terms? Okay, so if you want to write this POS, so you have to see the where you have zeros. Okay, where you have the zeros. So you will write like this, pi capital M. These are the max term. So you will see the where are the zeros. Zeros where are the zeros? Zeros are at 0. Okay, and 2, 3, 5 and 7 places. Okay, see here. See here. You have a 0 here at 0 position. At this position we have a 0. At this position we have these zeros. You have to check the F value F. This is a 0 at 5th position. This is a 0 at 7th position. So you can write like this. Okay. So two forms are there, SOP and POS. In the SOP you will see the where you have the ones. For POS you will see where you have the zeros. Simple. Okay. So you will write like this. If you want to write the max terms, you can write like this. So for writing the max term, okay, 0 will be considered as a 1, 1 should be considered as a 0. So here you can see here, this would be A, this would be B, this would be A, this would be B bar, this would be A, this would be A bar, this would be B, this would be A bar, this would be B bar, because this is the max term representation, this is the POS representation. So you will write like this. Okay, that will be given by capital M. Similarly for this 3 variables, so that would be A, B, C, A, B, C bar, and so on. You can write like this. Okay, so this is how we can write the min terms and max terms. Okay, if you want to find out these max terms, so you have to see where you have the zeros. Now again you see this is a 0, 0, again 0 is here, 0 is here. So this is the 7th position, 6th position, this is the 1st position, this is the 0 position. So you can write like this. More accurately you can write like this, function of A, B, C, that will be equal to pi capital M 0, 1, 6, 7. Okay, this is how you can write, and you can write the corresponding expressions. Okay, so this is all for today. Okay, we'll meet in the next lecture. Thank you.